Hello everyone, and this is Justin, and I would like to talk to you about the user interface for the Senior Capstone project. The purpose of the interface is for the user to pre-paint a copter flight path and other actions the copter performs. The interface should be simple and very straightforward to use. The next section will be about the interface design and the features that are presented on the interface. To code this interface, I have used C++ with the Qt API. Right here, I have the interface displayed. The interface is separated into three main sections. There are the user GPS input section, the map display section, and the waypoint display table section. I'll be explaining the functions of these three sections next. Over here at the user GPS input section, there is first the console window. The console window mirrors the scripts that the user is pre-planning or any other important information that the interface has to display. There is the 5-line input shown here where there is X for longitude, Y for latitude, Z for altitude, dir theta for direction angle, descent theta for angle of descent. After these parameters are filled, there are 5 options on the right where the user can designate. The 5 commands listed here is move, land, ascend towards, return home, and start and stop recording. What these functions does are all listed in the table displayed on this slide right here. In the center, I have the map display section. The map display section features an onboard display using Google Maps API and an HTML JavaScript page. There is also an input for latitude and longitude and height below to also enter waypoint, which functions exactly like move in the user input GPS section. Over here, the user is also able to set the home point, as well as move the map around and display or hide the path that the quadcopter is going to travel. On the right side of the interface is the waypoint display table. All waypoints entered in through the move on the user GPS section or the add waypoint in the map section are all listed right here in the order that the user has inputted them in. The user can click on the waypoint entry in order to select a waypoint, and then the user can delete the waypoint if desired. Or if the user really needs to, the user can click on clear all to purge all waypoints from the wait table. Finally, there is also the menu options above, where there are additional functions that have not been displayed out on the interface out here. Now, I'll show you how to actually use the interface and the features that I have previously talked about in the design. Before I actually demonstrate the interface, I would like to talk about the concept of the profile. The profile keeps track of the scripts based on the user input. It is a list of all the inputs that the user has inputted. The profile is what is set to the automation script, which script format is in JSON. So whatever the automation script receives is the JSON script based on the profile that is saved. The user input to JSON script format is shown right here. There is a JSON script for each of the functions I mentioned in the user input section, as well as the set home from the map section. One more concept that needs to be mentioned is the home. The home is not a waypoint because it is the starting location of the copter. The copter starts from this location. It is not a point that the copter travels to, with the exception of the return command. The home has the latitude and the longitude of the place of where the home is located in. I have opened up this interface using Qt Creator to show what is going on. I already have the coordinates inputted as I have several preset ones in the test debug menu in the autofill coordinates. The first step I have to do is designate a starting location as a home. With the coordinates entered, I click on set home. Google Maps takes a while to update, but eventually there will be a confirmation message when the waypoint is on the map. Over here it says that the home point is added and is shown as a blue marker on the map. The next step after adding a home point is I can then add further waypoints after that. After I have entered in the coordinates, I can click on Move. Once again, Google Maps takes a while to load, but it will be on the map shortly. Over here, I have the other waypoint shown. It is also updated in the waypoint table over here. I can then designate additional functions that the copter can do after it travels to its waypoint by clicking on land, descend towards, go home if it needs to, or it can start and stop recording as well. All the functions that I have performed so far is saved in what is I've referred to as a profile earlier. To show what a profile looks like, I can go to Show Profile, and these are all the commands that the copter will perform once the script is finally sent to the automation software. Currently, I would like to talk about how to select a waypoint. Right now, I have 4 different points, a home point and 3 waypoints. I can actually demonstrate these by clicking on these waypoints. In order to select the corresponding waypoint, for example, I want to pick waypoint 2, I have to go to the waypoint table and click the n-1 entry. So for now, the entry number 3 will refer to waypoint number 2. Now that I have it highlighted, suppose I want to delete it. Then I can just click on the delete. It will take a while, but after the Google Maps update, we will see a deleted entry. It is displayed right here. Waypoint deleted. All additional commands after this waypoint are removed. The last important component is socketing. When an external autonomous script is started, it will have a port number. I can enter this port number in the interface to connect to it. Afterwards, I can load a profile to the automation script either via the execute profile button or the sage profile button. Now, I'll demonstrate how the interface can send a message via socket to an external automation program. First of all, I have a profile saved already called socket demo, and here is one JSON script. Now, I will run the test Python script. As you can see right here, the open port is 58697. Now I go to enter port number and go to 58697. Port number is entered and now it is connected. I can now go to profile, load and execute, and go to the socket demo that I just showed you. This is what it displays, and now it's being sent at the moment. So the move absolute is being sent. If I open the script right here, I also receive a move absolute as well, confirming that the socket communication works. After the profile is sent to the automation software, it's up to the automation software to send the commands to the copter. The profile is now out of control of the interface. For more information on the interface, please check the report for further explanation on the design process, as well as detailed descriptions of every function that you can perform using the interface.